You're now at part 3 of the 7 secret causes of sweet and carb cravings that your healthcare provider doesn't want you to know about, because if he knew or she knew about it, she'd be out of business because you no longer have sweet and carb cravings. Kind of stumbled through that one a little bit, but okay. So in part 1, we went over the 7 causes. In part 2, we elaborated a little bit on blood sugar. And now we're in part 3, where we're going to go over the physiology a little bit more. So go ahead and have a seat facing this way while you're so comfortable lying down there. Now when we check the ileocecal valve is extremely important, because if somebody's having trouble with their ileocecal valve, that means they have a digestive concern, a digestive disorder, that's interfering with their ability to digest and absorb nutrients and then make them available for use, for whatever physiological use there may be. So if a person's not able to digest and absorb certain fats and certain carbohydrates and certain proteins, then they have a lot of trouble with their blood sugar. In fact, it's interesting because many of the fats that are needed to have good liver function and healthy gallbladder function and to get out of pain are also necessary to carb sugar cravings. And those fats are metabolized to a large extent by the gallbladder and the liver. So if a person's having trouble with their gallbladder and their liver, then they're going to have trouble with their blood sugar. I don't know if you're able to see how those things are all connected, but for sure, the liver releases glycogen in the bloodstream. The glycogen is sugar, essentially. It's a complex sugar, and it's broken down into glucose. So there's glucoses that are bonded together by hydrogen bonds, okay, most things are bonded together by hydrogen bonds, and then they break apart and the glycogen becomes glucose, and then you can create more sugar in the blood, okay? So if the liver's releasing too much glycogen or too little glycogen, the blood sugar goes up a little bit too high or a little bit too low, okay? And then there's other glands and organs that need to kick in and function properly. For example, the pancreas. We just found that Yvette was having a little trouble with her pancreas and adrenal gland blood sugar circuit, the pancreas being over in this area, and the adrenal glands are on top of the kidneys over in this area. I know I'm kind of poking and prodding at her, but we've gotten to know each other already, so I'm not being inappropriate or anything. So at any rate, the pancreas has a variety of hormones that are very important. For example, in the A cells of the pancreas, glucagon is produced, and the insulin is produced in the in the D cells, as far as I remember, in the islets of Langerhans. Okay. In the B cells. So that's not correct. In the B cells, we produce insulin. Okay. And in the D cells, we produce the somatostatin. So, okay, I know it's a lot of information, but the A cells, again, are producing the glucagon, the A and C cells, okay? And so this glucagon is very important for lowering blood sugar. And then we have the cortisol, which comes from the adrenal cortex, which raises the blood sugar. And then we have insulin, which also tends to be anabolic. Anabolic means it builds up tissue. So insulin is pushing fat, sugar, and protein all into storage areas, okay? But it especially pushes the fat, okay, into sugar storage. Sometimes people say, well, when you become diabetic, you have trouble with insulin, you need to take insulin. Well, that's true, but they don't understand why, and there's a whole lot to it, okay? So that's not the purpose of this video, but let's just say that when a person's having trouble with insulin, that's not such a good thing, okay? That's the B cells of the pancreas and the islets of Langerhans. They're just not, there's a problem there. Usually the person's given the insulin because they become hypersensitive to insulin, meaning their insulin receptors aren't working properly because their insulin levels have been so high, so high, so high, so high for so long that in order to keep emergencies from happening, they just give them the insulin to take. For some diabetics, every diabetic's different. Okay, the somatostatin is like growth hormone. So the somatostatin will send a signal to the pituitary and tell the pituitary to change the levels of certain hormones. It's a very complex hormone, the somatostatin. It's not so much that it's like growth hormone, it's a little bit more like the opposite of growth hormone, but because it's such a complex subject, and that's not really the purpose of this video, I didn't want to go over it in detail. But what is the purpose of this video is to show you that we can actually access these points that way, and then we can do so much more. For example, let's say I wanted to energetically check to see if Yvette was having trouble with, insulin or whatever. Like, I have all these different vials, and these vials have the energy of insulin, the energy of glucagon, the energy of somatostatin, the energy of these hormones, and I can just check them and see if they change things for Yvette. So I would take out one of them and see if it caused a change in her physiology. So yeah, there's just a whole bunch of, there's so many hormones here, I just don't know which one to pick. I just don't know which was my favorite, really. So we're kind of talking about the pancreas and the adrenal glands, but here's one. It's called an insulin-like growth factor. So IGF, insulin growth factor number 2, insulin-like growth factor. That sounds like it's related to the pancreas. Here's another one, insulin-like IGF-1 growth factor. So we can put it up to her manubrium, up to the self point, and then we can just check and see if there's a change. And she doesn't have a change. If there were a change, that would mean she was having some kind of difficulty of some sort or another with insulin-like growth factor IGF-2. We can just do it with another one. Hopefully you're liking this. Hopefully you're finding this helpful, because nobody else is helping you with this. You're watching this video because you're looking for a solution. What you're doing hasn't been working well. I'm just letting you know. If it had been working great, you wouldn't need to watch this video and look for another solution. I'm not trying to be disrespectful in any way, but we need to be honest with each other, right? So that doesn't seem to be weakening either. So there's no therapeutic need right now. I diagnosed nothing. That's what I'm showing you. I'm showing that I'm diagnosing nothing. If we were to diagnose something, we would expect the muscle to get weak, right? Showing an imbalance of some sort. So I could take something that might weaken and then see what would happen with that thing. Okay, so we could put something there, and if it weakens, then we can provide some kind of therapy. In this case, she just doesn't need this thing, sort of like she didn't need these nutrients. There is a point to all this. The point is that we have a whole language to help people with their health. That's not available to most healthcare providers, and it takes a different set of skills and a different set of training, and not everybody has the skills and training. Fortunately, I worked hard enough to get those skills and training. So thanks for coming out, and we look forward to finding out other ways we can help you with your blood sugar and your sweetened carb cravings.